Now we're going to prove the negation laws. Negation sign means? The negation sign just means not, is not. And so that means P or is not P is logically equal to T. The first thing we need to do, we need to write our statement variable / component, and then we go write out the truth value for it. It's going to be true and false. So then we write out our negation P, because that's our following statement variable / statement. And so here you can write false, true, right? Because it's going to be the opposite of P. That's going to be like this, and then this is going to be our tautology. And so what does a tautology mean? It means it's true for all, so we know this segment of our truth table is going to be true. And now we look at our finished sentence statement P or negation P. And we can see this is true, one is true, then that's all that we need. Doesn't matter if the other statement's false. So that's true, true, and so these are all logically equivalent to each other. And so these are logically equivalent to each other, so we say right here, where we bring this over and we say thus, we did this, we proved this. This is going to be the proof for the AND statement, this is going to be the proof for the OR statement, right? And OR. And so I only pointed it out just in case you didn't know. And I hope you're starting to see the problems the way that you should see it. So this is going to be P, this is going to be negation P, and then this is complete sentence / compound sentence, sentence statement. And so we use a lot of words, similar words all the time, that are similar to each other. And so we have P that's going to be true or false. And it's going to be the opposite of that, right? It's going to be false, true. And if you don't know that, then just take a look at the P on the opposite side. That's true, then opposite is going to be false. That's false, that's going to be true. And so now we got to look at the combinations of both. And so if both aren't true, then an AND statement is false. If both aren't true, then the AND statement is false. And if both are false, the AND statement is false. So these are both false. And so the contradiction statement is false for all given truth values. And so it's going to be false, false. And so therefore, what's our logical equivalency? Equivalent to each other, right? Because false and false is logically equivalent to each other. These are logically equivalent to each other. These are logically equivalent to each other. So this is going to be P, and negation P is logically equivalent to C. And so therefore this is going to be logically equivalent to that. And therefore we're going to put this down here and we say thus we prove this statement. And so I hope you understand what's going on. We prove the negation law. And if not, I hope you could go watch my other videos to understand this, and I explain it a lot more thoroughly than I do right here. And so I'm looking just in case I didn't mess up. And so I want you to do the same thing for you. When you make truth tables, is always look at if you made a mistake.